Hello, my name is Eduardo. I'm just going to show you how to do project one with Ozbay for high speed. And this is the project right here we have on the right on the screen. So it's about a 2D simulation of a CD nozzle and fluent. That's the first part. We're going to get all these contours and then the variables against using the center line. That's going to be the axis. And then we're also going to do the same, but the simulation of a shock in a CD nozzle and fluent. So for the first part, this is what we do. I'm just back here using a workbench for answers. So we go to your geometry and it's going to show you what I did. So for the geometry, this is what you should get. So first, what you should do, just create this curve right here. And then after you create that curve, you're gonna use like a line from this point to the axis, and then from this point to the axis, and then this line. I'm just gonna show you how to do that curve. That is gonna be a sketch and then equation, and you're gonna use that curve as equation. That equation is the one that's given in in this project, this link that the professor gave to us, show you the curve, the equation that you're gonna use. So this is what you need to do, is go under the sketch tab, select equation, then you're gonna use a curve type. The curve type is gonna be custom. These are the limits. If you don't see the curve, use change your scale to 1000. In the new one, I'm using Workbench 2022. You don't need to do that because as soon as you change your units, that's gonna change as well. So just keep your scale as 1 if you have Workbench 2022. Then enter this equation for the definition for y. And so from here, square all this, that's what you're gonna do. And then you're gonna get this curve right here. If you do that, then you draw these lines from point to axis, and then this and this. So the nozzle, actually, this is just half of the nozzle, but then when we go to Workbench, we're gonna do the mesh, and then once we send up the results, we're gonna do a symmetry to the axis. So this is gonna be the same this side and this size, and that's when you're gonna see that's what you're gonna see in the results, because we're gonna be using this twice pretty much. Okay, after we're done with geometry, we just go here to mesh. So here, what we need to do, just select this object, and we're gonna create a mesh. We're gonna use the face meshing option. This is the one right here. So the face meshing, and then the body sizing, you just put the size that was given to us. Let me see if I can pull that up. So yeah, you choose the body sizing that you need, then use the face meshing, and then you get a name the edges, so you can know what you're referring to when we're gonna be using that for the results. So inlet, I use your edge tool to select this, and then create this name selection as inlet. Then the outlet, of course, over there. Then the wall, this is the nozzle wall, and then axis. This axis right here, that's gonna be the center line that we're gonna use for part B. For our first part and second part for B, this is the center line that we're going to be using. It's this one right, axis. So very important to do that. Then just generate all that. Perfect. So we're done with the geometry. We're done with the mesh. After that, we just go to setup to see all solutions. So it's going to be this right here. Let's start from top to bottom. Let's start doing what we need to do so you can see what we need. So first of all, you start on energy. That's what we need to do. Then for the viscous, we're gonna use Invisit. So you choose that. After all that, I'm gonna go to materials and we're gonna check air. So I'm just gonna show you here, because the default, it's gonna be air, but we're gonna be using ideal gas for this. So you choose, instead of constant, just choose ideal gas, and then constant for here, and this is gonna be the value. So just change, create, and then close. After that, we're gonna go check the boundary conditions. So we just go here, and we're gonna edit for the values that we need. So on the inlet, let me show you what we have. So this is what you should do for inlet. It's pretty much the constant. And then for the outlet, this is one of the most important parts. So for outlet, we're gonna be using this. And then once you're gonna change this to chalk, we're just gonna change this part right here. That's for the second part. I'm gonna show you that later. First, let's do it with this. Okay, so after we have all those boundary conditions, we're ready to Boundary conditions. Yeah. So now, oh, here, let me show you. Yeah, this is all done. That's control. Okay. Perfect. Here, this we need to change this. So we just go to residual, and these are the values that you need. So we're gonna be using these values for your residuals right here. And after all that, we're ready to do the initialization. So we just go here. We're gonna do standard. I'm gonna compute from the inlet. So compute from inlet. Just check your values and you have all that. Perfect. Then go initialize, and that's it. After we initialize that, we're gonna run the calculations. So run calculations. I'll do 150 iterations. You can do more than that. You're more than welcome. Just do that. And then we're gonna start doing our contours and our plots for the first part. So you just go to contour, double click contour, and you're gonna get something like this. So here you choose what you're gonna do. So I just chose velocity here, then Mach number. Yeah, this is the name. It's Mach. So compute, and we're gonna use use anything. It'll do it by default, but just do that so you can see. Compute, save and display. And this is what we should get. So the Mach number. Start going subsonic and then start going a little bit higher and higher. So this is what we get. Perfect. And then we do the same with all the contours that the professor is asking us. So for the speed of sound, that's a little tricky one. I'll show you how. So here, instead of doing velocity, you're gonna go to properties. And then here, you're gonna go to sound speed. And then, yeah, compute, save and display. And then we got the speed of sound. So then for velocity magnitude, it's the same. Velocity magnitude, compute, save and display. That's it. So this is what we're gonna do for density, temperature, pressure, all that. We're gonna do the same. And then for the plots, so we're gonna go here to plots, go double click, you're gonna get something like this. And then you see your plot. Now, this is the part where you're gonna select the axis as your center line. So we're gonna do Mach number for this, so velocity, Mach number, then choose right here the axis. That's the center line we're gonna be using for the plot. And then save and plot. And here we go. This is what we get for the Mach number. That's the plot. All right, so you keep doing the same for all the plots that we need. So sound, velocity, density, temperature, pressure, all that, it's right there. And after that, we're ready for the first part. We're gonna get all our contours, all our plots. So then we go for the second part. For the second part, the only change that we need to do is the one I just told you about. It's you go here to boundary conditions and the outlet, I'm gonna edit that. And instead of doing this pressure in the outlet, we're gonna do something that will make this chock. So I'll do 16,000. Apply. Right. So apply one more time just in case. Close. Perfect. So we apply that boundary condition. Then let's do the initialization one more time just in case. And compare from inlet. Just in case we're gonna just redo everything from the boundary condition going down, we're gonna redo everything. Perfect. So this is all done. Then I'm gonna run our calculations. We're gonna do the same 150 iterations. Then calculate. Let's see what we get. Perfect. It's gonna take its time. Perfect. All right. So I just changing everything for the values that we got. So let's make sure we're doing this right. So after that, let's check again boundary conditions. outlet, edit. Sounds good. Looks good. Okay. Let's go here to Mac. Velocity, Mac number. Compute, 7 display. Yeah, so it should be pretty much the same. This is a comparison because I have this one from the other one right here. Mac number. This is for the first part. So yeah, I think pretty much the same for the Mac number. Yeah, all right. Let's see where we go for the rest. Should be the same. Let's see pressure. Pressure. Okay, I think we may need to go a little bit higher with our exit pressure for that. Because we get the same. Let's see. So let's go boundary conditions. Outlet. Let's edit that. And let's do 1 more 0. Let's try one more time. Adding 1 more 0 to that outlet pressure. All right. Yeah, I think that works. Where we need it. We're gonna see the changes now. Perfect. We're gonna start getting that pressure at the end. All right. Perfect. So let's take a look to all these contours that we got now. So for the Mach number, yeah. So you're gonna get this. It's a little bit different. Got the chart right here. Let's go check pressure. Yeah, so it's a little bit different. It's gonna be check at the end. Total temperature. Perfect. Yeah, it's gonna be the same. All right. Perfect. So this is all for our project, part 1 and part 2. So for part 2, just change your outlet pressure to make it shock nozzle, and that's it. Then just get your contours, get your plots, and repeat all the process as same for part 1. That's all. Thank you so much. Good luck.